Hello, my name is Hilary Weller and I work in the Department of Meteorology at the University of Reading. I've recently had the great pleasure to spend 2 weeks working in China at NUIST, which is the Nanjing University for Information Science and Technology. In the meteorology program there, we have a joint degree between Reading and NUIST in meteorology. And I went out there and I was teaching part of on this meteorology course. I was very new to me. I was teaching about meteorological measurements and instrumentation. I was lucky enough to find this book written by Giles Harrison, who's at the University of Reading, which was very helpful in teaching me about this fascinating subject, so that I could teach some of the students in China. And I thought I'd like to make a video talking about some of what I learnt. So one of the instruments for measuring solar radiation is a pyranometer. Here are some photos of pyranometers. So the solar radiation or solar irradiance, the shortwave radiation, goes into this clear glass here and is measured by this pyranometer. There's a few different types. This one has got a shade ring, so it blocks out the direct radiation from the sun, which is the solar beam. Obviously it blocks out more than just that. You can see quite a big shadow. And then this one measures just the global solar irradiance, without a shade ring. So that's from the sun and the scattered radiation through clouds and through the atmosphere and things. This pyranometer has got a shade disc which blocks out just the sun. So if you really want to know all of the solar irradiance but not the sun, this is what you want. The disadvantage of this is you've got to make sure that this is exactly blocking out the sun, so it's mounted on this sun tracking device, whereas these shade rings only have to be moved once every month or so. So they're not such high-tech equipment, less to go wrong, but you don't get such an accurate measurement. And then here's these two pyranometers are part of a net radiometer, which measures the downward going radiation. This is the solar part, and this is the long wave part, and this measures the upward going radiation. So you've got a pyranometer without shading, measures SG, the global solar irradiance, including from the direct solar beam, SB, and the diffuse solar irradiance. Shade rings here, or a shade disc, can be used to block out the direct solar beam, SB, so that you can measure just SD, the diffuse solar irradiance. And then up and downward pointing pyranometers measure downward SG, S global, and upward or reflected SU, solar irradiance. One thing you can see here on the side of this pyranometer with a shade disc is another device pointing directly at the sun. This is a pyrheliometer. Here's a pyrheliometer by itself pointing directly at the sun. This is another instrument that has to point directly at the sun, so it has to be on a sun tracking device to measure the direct solar beam, SB. And this, because this points at the sun, it's measuring something different. It's always going to measure something more than if you're just measuring the downward component. So here's a diagram of, this is the ground and here's the sun, and it's pointing at an angle. And this angle here between the vertical and the angle of the sun is called Z, which is the solar zenith angle. And the pyrheliometer measures the radiation that's in this direction, which is going to be more than the downward component. And that downward component is going to be the SB multiplied by cosine of Z, that solar zenith angle. So then the global solar radiation is going to be the component from the sun. The global solar radiation is just the downward component. So that's going to be the direct component from the sun multiplied by cos Z plus the diffuse solar irradiance. So that's the scattered radiation from clouds and so on. So you get this SG equals SB cos Z plus SD. Now, one of the ways that I like teaching is rather than getting students to memorize things, get them to use the information. And this is when I was at Newest, I asked the students to read chapter 9 of this book, which is about measuring radiation, and answer some questions. So these are the kind of questions I like. This is the figure from the book, and the kind of questions that I like, both for in class and for exam questions, are asking students to explain what's happening in the book, to show that they can use the information rather than memorize it. So using information is really what the important part of understanding. So this figure here, so these figures are measurements from the University of Reading Meteorological Observatory throughout the very clear day, and this shows for each hour of the day. So this dashed line here is the top of atmosphere irradiance. This is something that's calculated, and it's the downward component only. It's not at an angle. And then SB, this continuous line here, is the solar beam. So that's measured from a pyrheliometer. Here SG is the global solar irradiance. And on this side we've got, for all these points, SG versus SB cos Z. So 3 questions that I'd like to ask about this figure. Why is SB, this line here, greater than SG throughout the whole day? Why is the top of atmosphere irradiance greater than the global irradiance around midday, but for the rest of the day SB is bigger? Third question, on this figure here, why are the dots always above the dashed line? So I would like you to have a think about those questions, and the answers will be in another video.